Hi everyone, welcome to Unit 4 equations. Again, another long unit. So our last unit was 8 lessons, this one is 10, so you will be having a quiz and a test. Because this unit is longer and long, we will not have the test within the first quarter, actually will fall into the second quarter. So the only grade that you will have before report cards start is a quiz from this unit. So make sure that you're taking all of your notes and doing all of your homework assignments, Google Forms, and ask questions in class. So lesson 1 begins on page 101. So we are starting the equations unit. So it will look very similar to the unit we just did, but you will see that these now have equal signs. So I can solve one-step equations. I'm going to circle equations here, and I'm going to put equal signs. So we are no longer just working with expressions. And these will be one step today. Then we'll do two-step and combining like terms, and then the distributed property. So we will be adding on an extra step every day. And we solve one-step equations by isolating the variable. Isolate means to get alone. So isolating the variable, get variable or the letter alone. So our goal in this unit is to get the variable alone, isolate it so that we know what x equals or y equals or z equals, whatever the variable they give us. So we're going to use inverse operations today to solve for the variable and to get the variable alone. Inverse, just like in chapter 1, means opposite. So inverse operations mean opposite operation. And remember, whatever you do to one side of the equation, you must do to the other side. So remember, whatever you do to one side of the equation, do to the other side. You have to keep a balance. You don't want to change the problem. We just want to move terms from one side to the other. I'll fill in the rules as the problems get a bit longer. So let's look at the first example. We have x plus 3 equals 4. So our goal is to get the variable alone, isolate it. We want to know what x equals, so I'm going to put a box around x. I want to move everything away from the x to the right-hand side of the equal sign, away from the x on the left-hand side. So I'm going to use my inverse or opposite operations. Some of you will find it helpful to put what looks like a wall here. We want to move the 3 on the left side to the 4 on the right side. They're like terms, but they're on opposite sides of the equal sign. So we're going to use opposite operations. So the opposite of adding 3 is to subtract 3. In order to do that and keep it balanced, whatever you do to the left side, you need to do to the right side under the 4. 3 minus 3 is 0. That's why I crossed it out. And now x is isolated. It's by itself. 4 take away 3 is 1. So in order for this equation to work, x would have to be equal to 1. Now we can check it. So I write down the original problem. I take my 1 that I got for x and I substitute it in for x. 1 plus 3 is 4, so that matches my 4 on the other side. So this checks. 4 equals 4. Some of you that have Mr. Berman might have done COPS or OPS. So C for check, right? Then original problem, plug in and solve. So if that's helpful to you, you can use that as well. Number 2, again, I want to isolate my variable. In this case, it's h, so I'm going to box it up. So I want to move everything away from the h. So the opposite of subtracting 18 is to add 18. I want to get my like terms together, but they're on opposite sides of the equal sign, so you have to use those opposite operations. A negative 18 plus 18 is 0. Those are additive inverses or opposites. H equals 25 plus 18. You are allowed to use a calculator in the unit, so if you need it, pull it out. Make sure you have it next to you. So 8, 9, 10, 11, 12, 13. Carry the 1, 2, 3, 4. So H would have to be 43 in order for this equation to work. So I again write down my original. Substitute in 43 for H. 43 minus 18. Now, if you don't have a calculator, you're going to stack and subtract. If you do have a calculator, just do 43 minus 18. 8, 9, 10, 11, 12, 13. So that is in fact 25. Make sure it truly checks. Don't pretend like it checks. Does 43 minus 18 equal 25? Yes, so it checks. So you guys have the opportunity to check to see if your answer is right or wrong in this unit before you submit a quiz or a test. So even if it doesn't say to check, you really should take that opportunity to plug in your answer and see if it works. Problem number 3, we learned in the last few units that no operation means multiplication. So this is 3 times m. The opposite of multiplying by 3 is to divide by 3. And we're going to show that division by putting a fraction bar, just like we did in the translating lesson. Whatever you do to one side, you have to do the other side of the equal sign. So whatever you do to the left, you have to do to the right. 3 divided by 3 is 1. Now, we don't have to write 1m. You could, but 1m and m are the same thing. So I'm going to delete and erase that 1. So now I have m is equal to 9. Now that I know m is 9, I can plug 9 in for m. So I'm going to write down my original problem. 3m means 3 times m, and now we have 3 times 9. So I'm going to plug 9 in, substitute 9 in for m. 3 times 9 is 27, which is what I wanted it to come out to be. So that is a true statement, so we are good. Problem number 4, again, your goal is to solve for that x, and x is being divided by 2. The opposite of division is multiplication. So I'm going to multiply the left side by 2 and the right side by 2. 2 over 2 reduces to 1. So I don't need to write 1x. I could just write x. So technically x is isolated. It is alone. 15 times 2 is 30. Again, you want to keep that balance. So if you multiply by 2 on the left, you got to multiply by 2 on the right. X is 30. Let's see if that's a true statement. Let's see if this works. So I have x over 2 equals 15 as my original problem. I take 30 and I substitute it in for x. So now instead of x over 2, I now have 30 over 2, which means 30 divided by 2. 30 divided by 2 is in fact 15. So I wanted it to come out to be 15. So that's true. Check mark. It checks out. Problem number 5, if it bothers you that the 6 equals is on the left-hand side, you can cross it out and move it to the right-hand side and solve that way. Either way, it's going to be the same steps. So the opposite of adding 2, again, your goal is to get at x alone, is to subtract 2. Whatever you do to the one side, you have to do the other side of the equal sign. 2 take away 2 is 0, so those are gone. So I have x equals 6 take away 2 is 4. I now take my original problem, which was 6 equals x plus 2, or x plus 2 equals 6. Substitute 4 in for x. 4 plus 2 is in fact 6. 6 matches the 6 on the other side, so it checks. Number 6, again, your goal is to isolate that variable, so I'm going to box up that x. The opposite of a positive 12 is to subtract 12. Okay, and I'm not subtracting 12 because of the plus in front of the x. I'm subtracting 12 because that 12 is positive, and its additive inverse, its opposite, is a negative 12. I now have a positive x, which is the same thing as saying x, equals negative 10 minus 12. Signs are the same. I add and keep the sign. So this should be a negative 22. So use that calculator. Negative 10 minus 12. You hear my son's iPad going off because I just told him to get off of it. Now his friends are calling him. Drives me crazy. So now I write down the original problem. I plug in my negative 22. So now instead of 12 plus x, it's 12 plus a negative 22, which we know is the same as saying 12 minus 22. But just go ahead and do 12 plus negative 22. And I'm going to do, signs are different. I subtract. I get a negative 10. Keep the sign of the higher number because I don't have a calculator handy. So it checks. Okay, so a couple more. Oh, there goes that iPad again. Sorry, guys. Number 7, this is negative 5x, which means negative 5 times x. The opposite of multiplication by negative 5 is to divide by negative 5. So even though there's a negative in front of the 5, does not mean you're going to add 5. There's multiplication happening between the negative 5 and the x. Some of you might find it helpful to do this and put parentheses around the x to show that's negative 5 times x to remind yourself. So the opposite of multiplying by negative 5 is to divide by negative 5. Whatever you do to the left side of the equal sign, you do to the right. Those negative 5s reduce to 1. 1x is the same as x. 40 divided by negative 5, you could use your tic-tac-toe board or your calculator, but a positive divided by a negative should be a negative. 5, 10, 15, 20, 20, 30, 30, 40. So we have x equals negative 8. Now again, when you're doing your check, you should always be plugging into the original problem. Now if you had positive 8 instead of a negative 8, and you'll see it wouldn't check out, and you should catch that mistake and be able to go back and find your mistake. So now instead of negative 5x, I now have negative 5 times negative 8. Negative times a negative is a positive, and 5 times 8 is 40. So this does check out. Number 8, I have b minus 3. The opposite is subtracting 3. In order to get b alone is to add 3. Whatever you do to the left side of the equal sign, you have to do to the right side. Negative 3 and positive 3 becomes 0, so I can cross those out. b equals negative 7 plus 3. Signs are different. I subtract. I take the sign of the bigger number, or use your calculator. B comes out to be negative 4. I write down my original problem. Substitute negative 4 in for b. I could change my subtraction to an addition problem by squeezing in the imaginary plus sign, or signs are the same, add and keep. I have negative 7 equals negative 7, or just straight up use calculator on that, and it does in fact check. So again, with this chapter, you're at an advantage because you can substitute your answer in to make sure it works in the original problem. The opposite of multiplying is dividing. The opposite of dividing is multiplying. The opposite of adding is subtracting. And the opposite of subtracting is adding. You want to make sure you're always doing your inverse or opposite operation. We'll do the try these in class for practice. Your Google form questions, the 5 that I've chosen, come from page 103. Again, be careful with those negatives. Use your calculator. And even though it does not say to check on the 5 problems I'm pulling from this homework page, I suggest you do a check, whether it's in a space on this page or on a separate sheet of paper, before you submit your answer in the Google form. Good luck.